video clip क्या है? Optimize screen sharing. Am I even recording, bro? I am, I guess. I'm just like adjusting my stream. Okay. Whatever. So, alright, bros. करते भाई stream अभी क्या है? What if I remove my cap? I mean, I know I look stupid, but बचा ही क्या है life में? So we can just like, ooh, oh, bhai, oh, okay. This I can do, I guess. If I keep myself in this corner, there's not gonna be a lot of. Okay, what if I open my terminal here? What do I go here? Maybe here. Okay, hold on. If I go and do, uh, let's see. No, not this, not this, not this. Um, okay, so, okay, I got it now. So I should perhaps place myself on the bottom right because your code is gonna be from left to right. So if I'm showing anyone my Vim or shit on my editor, they're gonna have to see this at least. So I can perhaps do this. Dude, I didn't know I could do that, bro. Okay, that was obviously a very. All right, this looks good. This looks good, bro. This pitch looks good. Okay, I should not be using cuss words, but okay. Okane kasegu watashi wa sta. Okay, anyway, so ये हो सकता है in okay, so this looks correct to me. Uh, uh, mm, 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 mm. Okay, this is also not pretty, not bad, bro. Uh, uh, yeah, cool. So I'm gonna share my screen now. Cool. अभी हम जाते हैं इधर, ठीक है? Let's see, we gotta do a calculation of the covariance matrix. Fucking hell, bro, इसको अभी भी निकालना पड़ेगा बैंचोद. कोई बात नहीं, life do be like that. So what I'm gonna do is I'm gonna go back, I'm gonna do ls. क्या किया जाए? Should I can just go into algorithms and commit it, right? I can do I can open up my VS Code. I can close these things, I guess. Cool. Okane kasegu watashi wa sta. Okay, anyway, sorry. So इधर में जाएगा और इधर में करेगा email. Cool. And पहला क्या था? So this is gonna be my first one, covariance matrix. So let's go. Let's get the problem number. इधर documentation बनाते हैं. क्या कर रहा हूँ मैं? This is the problem that you are solving. Okay, whatever, bro. I'd love to do this in NVim to be honest. So actually, you know what? NVim भी सीखना ही है, तो might as well do this in NVim, baby girl. So ठीक है, यहाँ पे है. So let's set up NVim. ls, ठीक है. अभी बात ऐसी है कि what we gotta do is uh, let's see. I'm just like okay, I have my NVim shortcuts right here. So I'm just gonna be like NVim, and I know the tree is usually command N. right? So I know if you want to find your files, then usually it's FF, and I can just do what is it that I want to try out right now? Covariance matrix, right? So the covariance matrix is what we want to try out. Uh, we'll do Q, right? Okay, sorry. Oh, okay, hold on. How do I navigate between uh so J goes down, I know, K goes up, I know. And I know that these are just panes. So let's see, nvim navigate panes, navigate windows, I guess. Uh Command window. Okay, so okay. So okay, hold on. No, it's not command window, it's like control window. Okay, hold on. Okay. Oh, what? You can do that? I didn't know that. Oh, wait, command or control? So it's command W followed by W to toggle between open windows. Okay, so you're saying, oh wait, hold on. Okay. Oh, this is no, these are not the windows that I want to do. Okay, hold on. Bro, what the fuck? What the Sigma? What the Sigma? What the Sigma? Hold on. I know I can just do cheat sheet and just check क्या करना है. Okay, toggle window is not nvim tree. I just want to do nvim में run command तो ठीक है. Previous sibling. Let's see. Do I need the toolbox? What's the point of this toolbox, to be honest, right? Like, I could perhaps write some, you know, could write some things here, but this is usually for my blindfolded Rubik's Cube practice. Let's see. This is comment line is GCC. That's fine. That's fine. Uh, file नहीं चाहिए. Buffer is fine. Buffer में क्या था? Go to next is just tab, right? That's good. That's good. Wait, hold on, bro. Uh, okay, tab is just doing this shit. Hell nah, bro. Uh, okay. Okay, so this is just one thing, right? Uh, let's see. Window is just leader V, leader. No, this is new window. I don't need this shit. Oh, window up. Okay. Okay. Oh, is that so? Oopsie. So, what the fuck, you know, bro? What the fuck, bro? Okay, sorry. And this is ये किस चीज का थीम है दोस्त? एस टैब क्या है, शिफ्ट टैब? ये तो बफर का है भाई, ये तो नहीं चाहिए मुझे। I just wanna do switch. Window up, window down. Is it control? Okay, sorry. Okay, anyways. Now, new vertical, new horizontal term, new vertical window or new horizontal term. Let's see. This is good. This is what we wanted, right? So, how do you resize this shit? Okay. चलना जाना भाई. Okay, sorry. And resize. Okay. Control W or equals underscore is okay. I see. So, uh, come on, dude. Okay. Hold on. This did something. No, I don't want this. I mean, anyway. Okay, hold on. I have to create a new mapping. Fine, whatever. I'll just do this. Okay, so let's go to this one. And I know that this is what I want to do. Right. I just say return the true for now, maybe. And I think I don't know. Okay, I think we don't need, but okay, let's just do this, right? Uh, of course, because sure, let's see, this is annoying to me because bro, what the fuck is this, bro? This is better because this is okay. Hold on. Uh, yeah, this is so much better, dude. Okay. What the fuck? Cool. So this was of course a function. We gotta do something here. Right. So this is good. This is good, right? Now, what we gotta do is okay, cool. So okay. You know what? We know the input here, so let's just go and like copy the input. Right. So this is gonna be my input. Uh, I don't know why, but cool. I don't know why, but this did not do autocomplete. It's just like very weird. But fine, whatever. Okay, hold on. Let's see. Vim, normal mode, cheat sheet. Editing is fine. Cursor movement is what I wanted to know. Okay. We jump forward to the end of the word, be backward to the start. Sure, this is just random. Okay. Sure, this is fine. Cool. Okay, cool. Okie dokie. So, okay. So, you know what we are doing here is like we are doing like one arrow, but this is very inefficient. So instead, you should just do chota b, like escape. You just do b. You just come directly at the start of the word. Boom. This is how real men do it. You can just hold it, and then it also works. If you want to like go to the very start of the line, you can just do like I think you get to the start of the line and just back to the start of the word, jump backwards to the start of the word, words containing punctuation. Okay. So if you want to go to the start of the line, you go to 0. If you want to go to this end of the line, you go to E. No, you want to go to E. If you want to go to the okay. So if you want to go to the end of the words, you will do E. If you want to do start of the words, you go E. So I see. So W and E. Okay, and B is just this. Okay, cool. Okay, so B and GE is okay, that's fine. Jump to the end of the line. So dollar is end, 0 is 1. Okay, this is good. I like this because I love this. I love this honestly because this is pretty good. Now the question is, how do you go to the exact character, right? Like move cursor matching. Okay, so say if I want to go to like if I want to go to 6, so I can just do apparently percentage 6. No, hold on. How did that move? Right? Move cursor Hold on. Move cursor to matching character. Push. Okay, so if I'm going here, suppose. Oh, okay, hold on. What do you mean? Oh, this is essentially going to the end. Oh my God, I get it now. So if I'm here, oh, so percentage essentially takes me to the end of the brackets, I guess. So if I'm here, it should take me to 3K baad wala bracket. Oh, so it's just gonna take me through these, but if I go here, it's gonna take me through these. This is so beautiful, dude. This is a game changer. So now, okay, so okay, I love this. I'm loving this so far. Uh, okay, hold on. Stop recording macro in Vim. Cute. That was good enough, I guess. Awesome. Man, the things that I'm doing, like learning basics, I guess, but fine. A man's gotta do what a man's gotta do, man. Okay, cool. So हमें बनाना है covariance matrix. Let's just see, man, covariance matrix. Let's just see the definition. Covariance matrix I know. Okay, you know what? Since we're here, let's just go to Anki. We gotta make that. We gotta make that. Why am I like why am I retarded, man? Okay, so where is Anki, bro? Sure. Oh, yeah. Fuck it. I did it. Install successfully. Restart Anki. Okay, I'm just gonna restart Anki real quick. Yo, so I had this ML wala thing, custom study session nahi re bhai. Yeah, ML questions, I guess. I'm just gonna start adding things here. I know I'm covering deep ML stuff, so just gonna be like creating a tag for that. Uh, uh, Covariance matrix. So yeah, sure, covariance between pairs of elements given a random vector. Fair. Can be also called a variance covariance matrix. Cool. Between pairs. Okay, fine. That's pretty straightforward. This we know. Covariance matrix is a square matrix. Square matrix. This is a better definition because more technical, I guess. The diagonal element represent the variance, and sure, that's fine. Uh, of diagonal elements representation. Covariance is cool. Positive, negative, and zero. Positive co. Oh, this is such a good thing that we wanted, right? So positive covariance indicates that the two variables have a positive relationship, whereas negative covariance shows that they have a negative relationship. Okay. If two elements do not vary together, they will, of course, that makes complete sense to me. So let's just like covariance matrix highlights is what I'm gonna write here. Okay. Oh, okay. How do you make lists in this shit, bro? Order lists, unordered list is just this. Okay. So gotta remember these shortcuts, I guess. Uh, terminal survival. Key survival. What the sigma? Sorry. Okay. Cool. Chill, baby girl. Okay. What the fuck? Who is emailing me? LinkedIn spam. Fine. No, I should probably do. So highlights is also known as variance covariance. Two pairs of uh cool. This is good. Okay, yeah. Uh, you know what? We should write it to not vary together. This is like better, I guess. Fair. Yep. Positive. Correlation. Is that? Do you think that's a better way of saying it? Uh, I don't know. I just don't know. I don't want to like casually use random words. So, you know. Okay. Q. This is gonna be so. This is gonna be a dimension related point, also known as variance covariance matrix. Gen knowledge, I guess. I can just call it. Okay, I'm not gonna call it gen knowledge. I'm just gonna call it. Uh, property. This is fine. Yeah, property. So there's gonna be like one uh relationship. So there's gonna be one point on dimension one on trivia. There's one on diagonal property of diagonal property. That's good. So just gonna add this bitch. Uh covariance. को so covariance matrix का formula चाहिए अपने को. So okay dokie. Look at the guns, bro. Sorry. Uh sure. So in general, we know that variance is just see दोनों formulas में कुछ ऐसा difference तो है नहीं भाई. Mu is just the mean of the population. So for every element that you have, for every variable that you have, you need to have like a mean of it. And you need to have total observations. And that's pretty much it, man. That's pretty much it. So covariance is just if you have two variables, दोनों का means निकाल दो. And yeah, cool. So let's do representation. Uh, so we'll use like a math block. Okay, so begin. Do they not have a matrix? What the sigma? Okay, hold on. What the fuck? Wait, hold on. What? I don't believe this. Okay, my bad. Hold on. Math jacks. Yeah, I mean, no, I know Math jacks does have. That's what I was doing though. Is this not Math jacks? Hold on. Uh, so inline Math jacks inline. So see, I know that between two begins, you can do like a. Okay, so if I do begin of a and like end of a What? You don't support this shit? What the fuck? Hold on, hold on, hold on. So if I go to Obsidian, maybe. Let's see. Uh, Begin. Yeah, get rid of this. Sorry. So this shit works for sure. Why does this not work in this though? And that worked. What the? Oh, so it was working. It was just like not ready to, I guess, for some reason. But it also supports this. But I wanna do this. Cool. I wanna do like a normal B matrix. This is exactly what I had done though, right? Hold on. It's all fine. This is fine. Good enough for me, right? My bad, bro. So okay, cool. So we just gotta do like var of. We don't want this right away. We know that uh x1 c dot. I think there's like an and here to like give you like enough space in between, but it's just a single and. Okay, cool. It's been a while, man. So I know, yeah. Covar. I'm just gonna say co x1, uh, x2, I guess, and oopsie daisy. Yeah, and yeah. So this is essentially the uh, like what the sigma, bro? Okay, co x2. Yeah. So um, where and say c dots and right. So again, this is how the general formula is. I'm just gonna be like doing v dots because I just don't wanna like yeah. So xn, this is also gonna be cov xn x2, I guess, and this one's gonna be like var variance matrix of just xn. This is essentially how the covariance matrix will look like. The diagonal will just be variance and everything else is just covariance. So yeah, I think I'm just gonna like right. So this is gonna be pretty good, I guess. You can just to make it look prettier, I can just do this bitch. Kill. So this is how the representation is. Variance is this, covariance is this. So variance formula should be something like this. Variance of x equals gotta be like some sort of like what the fuck, bro? So there's gotta be like a sum of like let's do like a fraction here, and it will be x of I minus like hat of x, right? Uh, and all of this will be divided by n. Okay, this is not just this. This got to be like right? So you will see mu is essentially my mean of the population, right? So okay, so we don't want population variance is fine, right? Population variance is fine. We just want like the again it's the same thing. We want like the sample variation and sample thing. So okay, and of course like we'll just say that our summation goes from like I equals 1 uh to something like n maybe. So this is how the summation will be. Uh and what we gotta do is in fact this rack, right? Just gotta go in here so that like this is like properly represented, right? And covariance formula is gonna be like something like this. So I'm just gonna cov x1 x2 maybe. I guess I can do that, I guess. So instead of like a hat, it'll just be like another thing and it'll be uh instead of x maybe I can just do like y because this makes a lot more sense, I guess, right? Just to like make it like uh yeah, y I guess. Right, perfecto, perfecto. And this is essentially how this goes. Also, there's one important thing. It goes to n minus 1 rather than n. So this is how it'll go. Like it'll hold on. I goofed up. Okay. So this is going to n minus 1. Uh, this I get it. This is n minus 1 for some reason. And this is also n minus 1 for some reason. Hold on. Number of observations in the data set. Why does the sample have one less? Uh-huh. Okay, whatever, dude. कुछ तो होगा. कुछ तो होगा. We'll come to that in a bit, right? Just do where uh hat x uh hat x equals sample mean for x. Hat x. Okay, I'm just gonna do hat of sample mean of x and y respectively, I guess. So this is how you wanna do it. I'm just gonna for sake of consistency do n minus 1. Hold on, let's just check real quick. Variance formula. It's always n minus 1. That's what I've seen usually. And the reason why it's n minus 1 is because like for every element, if you have like n elements, right? Uh, जब तुम hold on, so अगर मैं इधर गया, let's just see they have like a calculation somewhere over here, some BS calculation brother. So math का student का ठीक है भाई, तो 3 बोल दिया बनता है ने, मीन तो हो गया, ये भी हो गया. So subtract means from all observations. That's always n minus 1. We why okay, what the fuck am I doing? Why does ठीक है, it's a basic question. It's a good question though. That's a good question though. Nishant Gupta, thank you for this, brother. Why not use n? Now, when you calculate variance, you divide by the number of data points n. Why? It's simple to n minus instead. It gives more accurate. Like, what the fuck? What the sigma? Let's say you have a jar with 1,000. Okay, sure. Why do you divide by number 5? Okay, if you divide 5, fine, sure. Variance number that's too low, you can make the weights closer together than they are by simply dividing by n. Can give you a boost to the variance number. This makes it better estimate of how spread out the weights are. Really? That's it? Just to, okay, so you can use n. Okay, so this, I don't trust this guy. Okay, what does Khan Academy say?
Here's a simulation created by Khan Academy user Justin Helps that once again tries to give us an understanding of why we divide by n-1 to get an unbiased estimate of population variance when we're trying to calculate the sample variance. So what he does here is a simulation, it has a population that has a uniform distribution. So he says, I used a flat probabilistic
Oh my God, this is so
distribution.
good, bro. This is so good, bro. Okay, okay, so n-1 you use karna hai, that's what we gotta keep in mind. Now, why does covariance formula use n-1 in the denominator, right, baby girl? Okay, so the answer is supposed to be unbiased variance. Okay, let's just see.
0 to 100 for my population. Then we start sampling from that population. We're going to use samples of size 50. And what we do is for each of those samples, we calculate the variance based on dividing by n. We calculate the sample variance based on dividing by n-1 and n-2. And as we keep having more and more and more samples, we take the mean of the variances calculated in different ways. And we figure out what those means converge to. So that's a sample. Here's another sample. Here's another sample. If I sample here, then now I'm adding a bunch and I'm sampling continuously. And you saw something very interesting happen. When I divide by n, I get my sample variance is still, even when I'm taking the mean of many sample variances that I've already taken, I'm still underestimating the true variance. When I divide by n-1, it looks like I'm getting a pretty good estimate, the mean of all of my sample variance. This is really converged to the true variance. When I divide by n-2 just for kicks, it's pretty clear that I overestimated,
Okay. Okay. Let's do okay. Hold on. Empirically, n using n in the denominator underestimates the variance. Using n in the denominator for almost perfectly get the variance using n-2 and lower the denom overestimates the variance. Now, why is this happening?
Overestimated with my mean of my sample variances, I overestimated the true variance. So this gives us a pretty good sense that n-1 is the right thing to do. Now, this is another interesting way of visualizing it. In the horizontal axis right over here, we're comparing each plot is one of our samples, and how far to the right is how much more is that sample mean than the true mean. And when we go to the left, it's how much less is the sample mean than the true mean. So for example, this sample right over here, it's all the way over to the right. It's the sample mean there was a lot more than the true mean. Sample mean here was a lot less than the true mean. Sample mean here only a little bit more than the true mean. In the vertical axis, using this denominator dividing by n, we calculate two different variances. One variance we use the sample mean, the other variance we use the population mean. And this, in the vertical axis, we compare the difference between the mean calculated with the sample mean versus the mean calculated with the population mean. So for example, this point right over here, when we calculate our mean with our sample mean, which is the normal way we do it, it significantly underestimates what the mean would have been if somehow we knew what the population mean was, and we could calculate it that way. And you get this really interesting shape, and it's something to think about. He recommends thinking about why or what kind of a shape this actually is. The other interesting thing is, when you look at it this way, it's pretty clear this entire graph is sitting below the horizontal axis. So we're always, when we calculate our sample variance using this formula, when we use the sample mean to do it, which we typically do, we're always getting a lower variance than when we use the population mean. Now this over here, when we divide by n-1, we're not always underestimating. Sometimes we're overestimating it. And when you take the mean of all of these variances, you converge. And here we're overestimating it a little bit more. And just to be clear, what we're talking about in these three graphs, let me take a screenshot of it and explain it a little bit more depth. So just to be clear, in this red graph right over here, let me do this, the color close to it at least. So this orange, what this distance is for each of these samples, we're calculating the sample variance using the sample mean. And in this case, we are using n as our denominator, in this case right over here. And from that, we're subtracting the sample variance, or I guess you could call this some kind of pseudo sample variance. If we somehow knew the population mean, this isn't something that you see a lot in statistics, but it's a gauge of how much we are underestimating our sample variance, given that we don't have the true population mean at our disposal. And so this is the distance. This is the distance we're calculating. You see, we are always underestimating. Here we overestimate a little bit, and we also underestimate. But when you take the mean, when you average them all out, it converges to the actual value. So here we're dividing by n minus 1, here we're dividing by n minus 2.
Last few seconds.
Using the sample mean, and in this case, we are using n as our denominator, in this case right over here. And from that, we're subtracting the sample variance, or I guess you could call this some kind of pseudo sample variance. If we somehow knew the population mean, this isn't something that you see a lot in statistics, but it's a gauge of how much we are underestimating our sample variance, given that we don't have the true population mean at our disposal. And so this is the distance. This is the distance we're calculating. You see, we are always underestimating. Here we overestimate a little bit, and we also underestimate. But when you take the mean, when you average them all out, it converges to the actual value. So here we're dividing by n minus 1, here we're dividing by n minus 2. Distance, then to be clear, in this red graph right over here, let me do this, the color close to at least, so this orange, what this distance is for each of these samples, we're calculating the sample variance using the sample mean, and in this case, we are using n as our denominator, in this case right over here, and from that, we're subtracting the sample variance, or I guess you could call this some kind of pseudo sample variance. If we somehow knew the population mean, this isn't something that you see a lot in
I get
statistics,
it. Okay, makes sense. Right, sample, right? So the question is, in sample covariance formula, why do we use? This is because in sample covariance formula, you do not know the actual n. And hence your variance estimate will always be underestimated. Sample, okay, so sample less than population. Just gonna write size sample less than right. So pretty much why we do that. Cool. So we understood this bit. Now okay, cool. So now that we understand this, we just gotta write our code, right? So what I'm thinking is I could write something in oopsie. I could write something in pure Python, and then I could write something in NumPy and then time it, I guess, right? So I'm just gonna for I won't use it, but I'll just keep this imported, I guess. Now vectors, right? So I just have two vectors, but I need to be able to calculate the mean for every vector. So means is gonna be like this list, I guess. And what I'm gonna do is what I'm gonna do is I know I need to calculate the mean of so if this is like a so these are my vectors, okay. And these so these are like elements in my vectors. So when I do my matrix, it's gonna be like a 2 by 2 matrix, right? So it's gonna be this is one element, this is another element. So like sorry, anyways, what am I saying, bro? What am I saying, bro? So okay. For okay, so sorry. So vec in vectors, right? For vec in vectors, let's just do means dot append maybe some vec by len vec, right? This is essentially going to give us our means, right? So this is essentially equivalent to uh, yeah, this is essentially equivalent to, what is this equivalent to? This is essentially equivalent to like uh hat x, right? So this is going to be equivalent to hat of x. Now, I want to calculate my variance covariance matrix, right? So, okay, I can just do like dim, right? Uh, it's going to be a square. Variance covariance matrix is always a square matrix, so it's going to be dim equals like len of vectors. So we know that this is also going to be like it's whatever, right? So I'm just going to be like var covar. I'm just gonna like initialize a uh, uh, dim dim, right? So this is essentially gonna create like an empty uh just maybe I could just call it, right. So this should essentially create like a empty initialize like an empty variance covariance matrix, right? So what we can do is since we just got a, yeah, let's just do we know that the diagonals are gonna be like the same. Everything else is just gonna be uh if diagonals are the same coordinates, then you just use one formula, otherwise you just use like some different formula. So what I'm gonna do is I'm just gonna do for I in range dim, for j in range dim. We gotta put something in the output, right? If I equals j, pass else pass, and right, this is what you're going to return. Right, this is what you're going to return. Now, all I got to do is, all I got to do is, I need to essentially create a lambda. Not again, just a fancy function, right? I'm just going to call it covar equals, just going to call it like a lambda. So what all things do I need to pass in my covariance ka function? I need to pass it my x. So I need to pass it my x and I need to pass it my is x used anywhere? Nope. I'm gonna call it x and x hat maybe, right? So when I do pass it an x, right? I know that it needs to be like a sum of all the xi's, right? What am I doing, bro? Okay, sorry. Covariance matrix calculation example. Let's just confirm. This one was like a pretty boring one, and I don't like this. Okay, I know this is fine. They just, dude, this is fucking plagiarize. These assholes. Anyways, fuck him. Let's see. So I know that mu x is just, this is one of my vector. इसका ये तो हो जाएगा. So right. Okay, sorry. So instead of co-var, I'm just gonna call this var. So because we are calculating just var f is what I'll call it, like a variance function. So I know I need like x over here, right? So what I do know is yeah, let's just do a sum, okay? And inside the sum, we gotta do it's gonna be a list. Okay, it's gonna be a list of some values where it's gonna be xi, okay, sorry, xi minus x hat for xi in x. Okay, so this is gonna be our numerator, and this is just gonna be like len of x. So what we are essentially passing in here is one of the vectors, right? So output I j equals var f, and we will pass in this uh, doesn't matter if we pass a or b. So let's just say vectors of I and means of I, right? This would be I and j. And what we can do is diags equals like a set maybe. If if ji in diags or ij, okay, uh yeah, right. So else we'll just like create one more function here. We'll call it covarf equals lambda x hat y hat, and a large part of this is gonna be something like this. Oh, okay. So yeah, permanently, sure. Okay, so oopsie, we know this is going to be -1 because no. I'm just gonna copy this one. Right, so we know this is also going to be len of x minus 1. We know both of these are going to be the same. Uh, so I'm going to call in this x of I, y of I minus y hat for I in range dim, for example, right? And all I gotta do now is output, whoopsie. Yep. Uh, over f of vector I means of I, vector j, means of j, right? And sorry, and I can just do diag dot add ij diag dot add ji, right? So if one of them is present, I'm gonna be like, hey, you know what? I don't need ij because I just populated ij. It's never gonna go to ij, but this is how I think it should work. Uh, let's see. Okay. Of course, I should like probably okay. Okay. Right, this is vectors, this is vectors. Um Float object is not callable, sure. So it's only in the covariance function where shit is messing up, right? Covar f में x hat xi minus y hat. Oh my god, bro. Uh, this should have been the case. So something's up here, which is currently it's given me 0.51, 0.51. So something's not quite right. Is it my denominator? Let's just test, right? Uh, so my covariances are not coming out perfectly as I expected, right? What the fuck? Hold on, that makes zero sense to me. So 0, 1, why is it var f? Sure. Um, I was underestimating it, but this is good now. Yeah, ij is good. You have to pass in the whole vector, that's for sure. But why is when I and j is 0, why is it modifying 0 and 1? Okay. I think I may have some idea. I don't know if this is the so this is perfect. This is perfect now. You see, that was essentially because it had created a copy of itself. So never do that. Uh, we know that it's like the diagonals are perfect now. Okay, sorry. The diagonals are perfect. Something's up with my function here. Xi gotta be xi minus x hat, yi times yi minus y hat. And this the formula looks correct to me, honestly. No, so this is definitely the denominator is not the problem. There is something messed up over here. So I know that if output, okay, hold on. What if I, for now, get rid of this one? It shouldn't matter, but just avoids the calculation. So what I am taking in is vectors of I and vectors of j, taking in the means of j, right? It's got to be the sum of, okay, hold on. Maybe there is some minor issue here. Covariance if I try to calculate, right? So this looks good to me. Covariance of x and covariance of y, covariance of x and covariance of y. This is fine. So xi minus yi. Okay. This looks correct to me, but what we will do is, uh, sorry, just gonna print here. Oopsie. We'll print ij, we will print vectors of I, vectors of j, uh, and in no way it should be the expected output seems to be that, so I'm just thinking means I just wondering if any way the means are like not calculated properly. Yeah, for V and vec it's just gotta be right. So I know the 0, 1 and 1, 0, so um so means are this iska mean is 2, which is perfect, right? It's like 6 by 3 is 2. And iska mean is 15 by 3, 5, I guess. Yeah, of course. So the means are calculated perfectly. The issue is, I mean, this seems perfect to be honest to me, right? Like, so if I just try to manually calculate this, right? So it would be uh let's see. So it should be like 1 minus 2 times uh 4 minus 5 plus 2 minus 2 times 5 minus 5 plus 3 minus 2 times 6 minus 5, I guess. So this is 2, right? And this makes sense. So 2 by 2 is gotta be 1, which is what we expect here. So Yeah. So if it's something by 2, it's just becoming 1. Denominator 2 is gonna be the same thing, right? The sum upper is becoming out to be 1. Why is that the case? Right, that's the weird part. Xi. So vectors of I and vectors of j is perfect. I don't see a problem in this, honestly. Okay, so there's some stupid shit that I'm doing, I guess, somewhere. Let's see. Yeah, whatever. Hmm. Of course, bro. Wait, there should be something of length 3 though, not 2, right? So God, dude, this is such a stupid mistake, man. This is such a stupid mistake. God, man, I get it. I get it now. So the mistake was so stupid. The mistake was essentially uh, this dims that we did. This should simply have been uh, X. Yeah. What the fuck? Okay, sorry. Length of X, I guess. So my bad. God, I'm like goofing this up so bad right now. Yeah, yep. This was like stupid, I guess. Uh, could have done it better, I guess. Anyways, let's go here first of all. So this was supposed to be our solution, like raw solution out of like without any sort of uh these things, I guess. But submit code. There's an indentation error. Why, bro? So this is fine, I guess. Uh, is this problem number is this deep ML 20? Is that deep ML 20? It's deep ML 10. Deep ML 10 variance, covariance, matrix computation. This has been pushed. The fuck? Okay, cool. Now let's see. What can we solve next? Let's just maybe can I sort it by difficulty? Let's just do all mediums. What are mediums we have? We just have one page of mediums. So why is SVD still showing up if it's medium, right? This is stupid. Anyways, K-means clustering is actually pretty easy. Could do K-means, I guess. So initial centroids are these. These are the maximum number of iterations. Okay, okay. Cool. And okay. Uh, okay, cool. So, use this maybe, and okay. Let's just like go here and maybe just like fucking copy this shit. Ooh, little girl. Now let's go here and yeah, whatever, bro. We need the input now. Input as points is this. K is 2. Okay, so K equals 2. Initial centroids are these, I guess. And max iterations are like 10, I guess. So max iterations are going to be 10. We're just going to be like points K initial centroids and max iterations. Fine. So this one's gonna be like Python. Currently, just gonna be like giving it like a 2, right? So let's see. Write a Python function that implements k-means algorithm for clustering, starting with specified initial centroids at the and set number of iterations. The function should take a list of points, each represented as a tuple of coordinates. Find an integer k representing the number of clusters to form a list of initial centroids and an integer representing the maximum number of iterations to perform. Sure, the function will iteratively assign each point to the nearest centroid and update the centroid based on the assignments until the centroids do not change significantly. Fine. Or the maximum number of iterations is reached. Sure. The function should return a list of final centroids of the cluster down to the nearest fourth decimal. Sure, cool. So the output is, why are they saying the output is like 1, 2, whatever? Because they themselves, anyways, I'm just gonna start coding here. I'm just gonna like write my strategy. Strategy is gonna be iterate through okay, so for num iterations, iterate through the points. Iterate through the points and iterate through the points, then for each centroid, find distance from point, uh, track min dist, uh, assign point to min centroid and its respective cluster. Once this is done for all points, I guess for each cluster, uh, update the centroid for its points. Cool. Return final edge. Right. So this is gonna be my approach, I guess. Uh, this is gonna be my approach. So should be pretty straightforward, I guess. But let's see. For each point, so my initial centroids are gonna be this something 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 something. And what I'm gonna do is maybe just for the sake of right, and what I'm gonna do is centroids, centroids. Okay, sorry, not centroids, not centroids. Okay, yeah, cluster centroids maybe. I'm gonna be like default dict, right? For cnum, cluster num in range of k, so we have like two of these, right? I'm gonna be like cluster centroids cnum is gonna be equal to initial centroids ka cnum, right? So we're essentially saying that a particular cluster, we're just initializing this cluster centroids ka thing, right? And we're gonna create a dist function. I'm gonna be like lambda. We just need two things, right? P1, P2, these are gonna be points, right? I think I could just import like math or something. Okay, hold on. I think NumPy has like a nice thing. NumPy distance between 2 points. I think they have like a nice cute little function for this. Nah, fuck nah, I'm not doing this. Okay, anyway, you just write this from scratch, import math. Okay. From math, import everything. Right, so let's just do this, right? Return. No, you don't need a return lambda. You just simply do sqrt of sorry p10 minus p20 square plus yeah, p1 1 minus p2 1 square. So this is just gonna give us like a distance function, right? Now for id in max iteration for id in max iterations, it's not that we give a shit, right? You can just like make it empty, I guess. For all of our iterations, what we're gonna do is for p in points, right? For p num in range. Okay, hold on. What I can do is right dist list, I would say, like dist val, I could just say dist f of dist f of like points, like that particular point p, and cluster centroids uh cnum for cnum in range of k, right? So I'll get the dist val, right? Now what you got to do is right. What I'm thinking I can do is like instead of just p1 p2, like I just for the sake of my convenience, right? I'm just gonna like say cluster number, and I'm gonna make you return the cnum, okay? And in here okay, sorry. So in here I'm gonna be like cnum and right uh and plus equals min of dist2val. Let's call it dist2vals because it's gonna be like better that way. So I'm passing in the point, I'm passing it the cluster centroid, and I'm passing it the cluster number. And this essentially returns minimum distance, and the second value is essentially gonna be the cluster number. And what we got to do is we just got to do like an assignment for each cluster, I guess, right? And what I'm going to do is I'm just going to be like maintaining a uh, uh, plus assignment equals default dict of int, I guess. Cool. Okay, sorry, my bad. So default dict of not int, but rather than that, it's going to be like a list. This thing is going to be like a tuple, right? Right. So what I'm going to do is clust assignment dot append. I'm just going to do like p. Sorry, not this is going to be clust append of clust. So that particular cluster number is going to get like my p here. Now we just do update centroids, right? So for um Motherfucker today. So for update centroids, let's just do a function called new cent f equals lambda. We'll call this xl yl, like lists of x and y, and this just gotta return like okay, p is points is what I'll say. uh pp0 for pp in points by len points. Then there's got to be like a sum. Okay. Points, and got to be pp1 for pp in points, right? So now for kv in clust assignment dot items, right? So right, so uh clust centroids dot k. Okay, hold on. Phenum c vals phenum equals new centf c vals, right? And this should be done, and we should be just returning clust centroids dot values. Right, this is how I'd return it. Right, so let's see, this is how I think it should work ideally. Let's see if there's any typo error anywhere. So cluster centroid is going to be defaulted with tuples. For CNUM in the range case, it's going to go to 0 and 2 for whatever input we have been given. CNUM is going to be initial centroids.cnum. So we initialize our centroids with whatever we had in CNUM. This is going to be index. This is just going to be like a key. The distance function is just a square root of uh diff just the distance function, like a Euclidean distance, right? And you return also a CNUM, right? Now my new cent is essentially sum of pp0 for pp in points by len points. Sure, this works for all iterations. Cluster assignment is going to be an empty text for p in points. Distance value is going to be a distance function of p, which is the first one. Cluster centroids is CNUM, which is going to be a tuple. It's just going to have one value. CNUM is going to be the cluster number. So when it finds the min thing, it's going to get the cluster. And the cluster assignment cluster is going to get some points assigned to it. For CNUM in this, it's going to be doing this. And yep, let's see. I don't know. Int object is not iterable. Yes. So iterations is something that where I'm messing up quite a lot. Because I should be adding a range here, right? This was like an obvious stupid thing. Anywhere else for field points, okay. Cluster centroid is not defined. Clusters Cent, cluster, cent, cluster, cent, consistent, plus, cluster. Okay, so, okay, cluster, I get it. Cluster, centroids. There could be some typos still. Tuple is not callable. Tuple is not callable, so dist values. Dist f is gonna be a lambda, right? Dist f is getting three things. Cluster centroids. Cluster centroids is what? Cluster centroids is tuple object is not callable. Why though? Okay, let's see. P cluster centroids phenum phenum dist f. So I get it now. I get it now. So it's me being a bit over smart and just doing this. So uh right, this is how it should have been, I guess. Um um the sigma. So 1 2 10 2, is that what we were expecting? 1 2 and 10 2, cool. So exactly what we wanted. So there are a few mistakes that we made, like silly mistakes. One was a typo. Okay. So one of the mistakes that we made was it was a typo, right? So that's fine, I guess. What we can do is, I know we gotta round this to the nearest fourth decimal. So what I'm gonna do is, so I know. Huh. The fuck did I do, bro? So let's see, you can just copy this entire thing and go here and see if this is something that they accept. They want nearest 4, right? Why is test case 2 rejected? Input was clustering. 2 clusters you want. For 0 0 0. Oh, okay. I didn't generalize it. I just assumed this is gonna be like a two-dimensional thing. Got it. I get it. So it won't just be like a two-dimensional thing, right? Uh, so okay, I did not expect this shiz to happen. So let's go here, maybe word wrap, kill. Nice. So let's do something. We'll call it def dist distf, right? And we'll be like points and phenum. We'll do points centroids phenum. Cool. Now what I'm gonna do is just take this shit from here, I guess, right? So we gotta generalize this shit, right? So we know that LE equal, okay, L equals len 0.0, for example, right? Okay, not points. Right, point 1 and point 2, then point 1, right? So return sqrt of uh, points 1 I minus points 2 I, okay, square. So you return uh, for I in range L, right? So you return this and you return a CNUM and you remove this dist here forever. So you pass it this entire thing and it returns something generalized. Cool. Same with this one, right? So def new sent f, we just needed points, right? Just needed length of points, right? And we know that the return is simply going to be a size equals length points. Right, so it's just going to be um for I in range L, right, by size. So it's going to be sum of this, right? So round this by 4, right? And finally for P in points, right? So this is what I get essentially. And a tuple of this is what I want to return, right? So new f should be the same, I guess. Everything else remains the same, honestly. Nothing else changes. Uh, right. So right now, what we'll do is we'll test the outputs here, right? Let's just do this maybe. Must be a real number, not a list. So something's up in my dist function. Something's going on here. So point one and point two. So I go here, distf gets point one and point two. Um, so this, oopsie. So this should have been like a sum here. So right, so let's just comment this one out. No, hold on, something's going on here, right? So right, so my distance values are just these, which is perfect. And this gives me the cluster number, which is exactly what I wanted. So this is what I gotta figure out. It's giving 0, 1, and 3. Why is it giving 3 things? Cvals. Cvals is gonna be like a list of tuples. Hold on, what the fuck? Okay, yeah, this is fine. This should be a cvals, right? This should get points. L should be points of 0. Size should be the total length. So inside the tuple, I should get for not the two. Oh my God, I get it. I get it. This was like a stupid mistake. Uh, this should have been for P in points. And this should have been like this, I guess. Okay, cool. This makes sense to me. And if I comment this one out, okay, 0, 1, 1, 1. And if I go here, this should now work, I guess. Submit. Cool, this worked. So this was good. This is good. A few learnings. Do not assume that the K means will only be 2D, 2D coordinate system. It can, hold on, what the fuck is going on, man? In oh, so cool. So get status. Get add K means this is deep ML of back to problems. Deep ML 7, deep ML 17. K means code.